So in this lab number 6, we have introduction and implementation of timers and counters on ATMEGA 328P using Atmel Studio and Proteus. The objective of this lab is introduction of timer counter with PWM and introduction of two interrupts. And the timers are the best, are the heart of automation. We have seen in previous chapters how we could take an input, perform multiple mathematical functions on the data, and perform an action. Interrupt the program running on the controller is normally running sequential instruction over the instruction. And tools are here: timer counter, reference, and theory of operation. You can see here the clock source and send pulses base scalar, which is divided by now CRN is clock speed divided by scalar value multiplied by desired time in second minus 1. This is the formula for OCRN. Modes of operation: normal mode, CTC mode, fast PWM, and phase correct mode. In normal mode, the plus photo operation normal mode, WGM1, 01, counter direction are less intermittent. The function formula for this and fast PWM mode, the fast pulse with modulation or fast PWM mode is equal to 3, provides high frequency PWM for generation option. Phase correct PWM mode, of phase correct 01 provide high resolution phase correct PWM waveform generation option. The phase correct PWM mode is based on the dual slope operation. 8-bit timer counter at TCCROA and bit 7, 6 are COM A and compare output mode which are with N1 ratio 0. Compare match output mode. These are the bit combination are best set for OC0 output and connected to however node that data register correspond to OC driver. This is COM01, COM00 description, and this is the table and compare output mode. This is compare output mode for phase correct PWM, and this is for fast PWM. This is for non PWM mode, and this is very uniform description. Let's move on to our code. So task 1 is display counting TC and T register on LCD and also counting how many times the CND count is overflowing and showing by LCD. This is the code. 16 megahertz frequency include IO.h and this is header file include. Then we include header file of relay and std library.h. Output port B and C and initialize array. So let's move on to our simulation. This is our code we have elaborated earlier. So counter is counting and when we use counter every time it's count, and display on LCD. Task 2 to make a digital watch using timer counter timers on LCD. Move on to our code. This is the code of the header files including, and this is same. This is our array, minute array, second array, and this is function in a for printing, and this is for calculating hours. This is for minute, and this is for second, and this is for delay function. 1 millisecond delay. We use timer one and higher bit, and this is lower bit. This is a separate simulation. This is hour, minute, and second hour printed on LCD. Task 3 is count and extend the event that can be switched on and off, display on LCD or 7-segment display. This is the header file inclusion, and this is the port output. These are output, and this is input. And this is falling. TCC R1A is rising, and TCC R1B is falling. And this is CTC mode, while this is for printing, and this is the header file I explained earlier. So move on to our code. This is our code we liberated earlier, and this is counting when how much time we press the button, and this is counting on and printing on LCD. This is hardware implementation of task 1. This is for task 2 hour minute second, and this is for counting. So in this lab, we have learned about the basic concept of timer counter and different type of counter and the timers and their operations. We have also learned about real-life timer and counter examples and implemented a few of them. Thank you so much for watching. We'll cover next videos in coming session.